So now I am going to explain the difference between the saturated hydrocarbon and unsaturated hydrocarbons and which type of reactions are performed by these hydrocarbons. Saturated and the unsaturated word is not new for you. I have already explained. The saturated hydrocarbons are those hydrocarbons where all the four valencies are performed by the single bond only. And unsaturated hydrocarbons are those hydrocarbons where all the four valencies are not satisfied by the single. It may be double bond or it may be triple bond only. So first of all, I am going to explain the saturated hydrocarbons. This is a very important topic for your board examination. Saturated hydrocarbon. I have taken a very simple example of saturated hydrocarbon. This is methane. And you know, I have taken the structure formula, branched structure formula. I have made a branch. Look at this, CHHH. Suppose this methane is going to react with the chlorine. Chlorine, that means Cl2. So for the convenience, for the better understanding, I have written like this, Cl.Cl. Now, without the replacement of this hydrogen by the Cl, this reaction is not possible. Why this reaction is not possible? Because all the four valencies are there. So you cannot add chlorine like this because all the four valencies are satisfied by the hydrogen only. So first of all, you will have to replace or you will have to substitute this hydrogen element by this Cl. Then only this reaction is possible. That's why the name of these reactions are substitution reactions, and the saturated hydrocarbon only undergoes the substitution reaction only. The type of reaction that is performed by the saturated hydrocarbons are only and only substitution reaction, because without the substituting this hydrogen, any reaction in the saturated hydrocarbon is not possible. So what happens? This H is substituted HCl and it is forming the HCl, and the one more Cl, when this hydrogen is replaced, this hydrogen is substituted, that means this place is vacant, that means the Cl can be added over here. So the same concept is the same. Without making the methyl, okay, without making the methyl from the methane, you won't be able to add this chlorine. Firstly, you will have to substitute, or in other words that I have already explained in the last lecture. First of all, you will have to make the methane, you will have to make the methyl from methane. Then only this reaction is possible. And this type of reactions are known as the substitution reaction, that is performed by the saturated hydrocarbon only. So, in which the replacement of H, as I have explained you, by the Cl, or the substitution of H. Replacement or the substitution word both are same. Replacement of H or the substitution of H by the Cl. So, this is a final conclusion. It is the universal truth that means the saturated hydrocarbons only and only give substitution reaction only. Second point, that comes under the reasoning that saturated hydrocarbons are always less reactive. If you compare between the saturated and the unsaturated hydrocarbons, saturated hydrocarbons are always less reactive than unsaturated hydrocarbons. Why? Because I have given one example. I have made the structure formula, like branched structure formula of ethane, C2H6. C2H6, you can see the single bond is there. The technical name of single bond is known as the sigma bonding. Sigma and pi bondings are not the part of your syllabus. I am just introducing you. There is the sigma bonding, and always the sigma bonding or the single bond between the carbon-carbon is always a strong bond, and that it is very difficult to break that strong bond. So in this way, always and it is a universal truth. When we are discussing the saturated hydrocarbon, that means always the single bonds are there. So because of the strong bonding, the saturated hydrocarbons are always less reactive. So if we compare it from the alkene, suppose I have given one example here, alkene. Alkene means unsaturated hydrocarbon, in between the carbon-carbon double bond is there. So this is the sigma bond, single bond, and one more bonding is there. This is known as the pi bonding. Pi bondings are always weaker bonding. That means weaker bonding. So it is very easy to break the weaker bonding. So it has the ability to form the number of compounds. Number of compound, that means it is more reactive than the saturated hydrocarbons. More reactive means the number of compounds that are performed by the unsaturated hydrocarbons will be more if you compare it from the saturated hydrocarbons. So the final conclusions are that means the saturated hydrocarbons are less reactive because of a strong bond, and the unsaturated hydrocarbons are more reactive because of weak bonding, double bonding is there. Now I am coming to the type of reaction that is performed by unsaturated hydrocarbon. As the saturated hydrocarbon gives the substitution reactions, I have already explained. Now coming to the different type of reaction, addition reaction, that is performed by the unsaturated hydrocarbon. Look at this example. I have formed the structure formula. Remember that branched structure formula of alkene, ethene, first compound of the double bond series, unsaturated hydrocarbon, CC, double bond is there at C2H4, you know C2H4. Now when the C2H4 like ethene react with the chlorine, for the better understanding I have written Cl.Cl, Cl2 you can write like this, Cl.Cl. What happens? I have told you it is easy to break the double bonding. So what happens? This bond, this double bond is there, this bond, upper ones, pi bond, it will break, and when it will break, it will, one Cl will attach over here and one Cl will attach over here without the substituting the hydrogen element. You can see that hydrogen C2, hydrogen is there, but this bond, because it's the weak bond and it is easy to break this weak bond, so this bond will break when at the result of this one Cl will attach over here and the one Cl will attach over here and the compound will form. So without substituting, you are going to add the halogens, you are going to add the chlorine in this compound. So this type of reactions are known as the addition reaction, that is only and only performed by the unsaturated hydrocarbons. Saturated hydrocarbon cannot give this reaction, only unsaturated hydrocarbons give. So the type of reactions that are performed by the unsaturated hydrocarbons are known as the addition reaction. Addition, why these are known as the addition reaction? As the name indicates, because you are not going to substitute the hydrogen, but you are going to add the chlorine, because this bond is a weak bond, so it is easy to break this bond. So this chlorine element must be added over here, and without substituting hydrogen, you are getting the new product. In this way, there are the two questions that comes in the board examination. Which type of reactions are performed by the saturated? Which type of reactions are performed by the unsaturated? Why? Which bond is the weak bond? Which type of compounds are more reactive? So in this way, I am finally coming to the final point. That means saturated hydrocarbon gives the substitution reaction like this. Unsaturated hydrocarbons only and only give addition reaction. Reason? Because without substituting the hydrogen, this bond is weak bond, so it is easy to break this, and easy to break this, that's why these unsaturated hydrocarbons are more reactive than the saturated hydrocarbons.